Hi everyone, welcome to my channel Code with B. In this video we will look at data security. Before we start how we can secure our data, we will see why do we really need data security. To understand that, let's take one example. Suppose I want to send some message to my friend. Okay, so suppose I'm using some application here, and then the destination application is here. So this is person A, this is person B, and I have sent one message to this device. Say I'm saying I love New York, right? So I have sent this message. So this message is supposed to be reached to the user who is using this device. But somehow you started getting calls from some travel agencies. They're talking about the flight tickets and all, and you're getting random emails for the different booking options. But you were just sending this message to your friend. So there could be one possibility that your friend has told the agencies that okay, my friend loves New York, so he must want to visit New York, so he can arrange the bookings, right? But that is not the case. In this particular scenario, what happened is before this message reached to the receiving application, it has been tracked by someone else. That person, the thing is called man-in-middle attack. So while traveling this data through the network, this data can be captured by someone in between, and they can make use of this data in various forms. They can sell it out to some agencies, or they can use this data for different kind of purpose. But this is your personal data. This should not be available for anyone else, right? Similarly, there could be another scenario when you are using some banking applications, and you are sending your some information in the banking website. Say your account details or your personal information such as your PAN number, or in any other application you are sharing your driving license number and so on. So this is very personal to you. This should not be shared to anyone else unless you know who you are sharing with. So this information has to reach in the network very safely. Similarly, there could be possibility that you are using some social website, and you are using your credentials to log in, right? And this credential, your username, your password, again need to be verified by the that application, so that data is going to the server of the application. But before it reaches to the server, it has been tracked by the man in middle, and then they can use your identity, and you can never imagine what worse it can be, right? So you have to make sure that whatever data is transferring from one application to the other via the network has to be secured, right? So how can this data be secured? The simplest form would be like whatever data you have, it is transformed into some form. The transformed form of the data is traveling to the network, and at the receiving end, again the data can be converted to the original form. This transformation is actually the encryption. So for data security, encryption and the decryption are main ingredient. In this video, we will look at different aspects of the encryption and decryption. So let's look at how can we encrypt the data. Alright, for encrypting the data, suppose you have some message, say this is Bridge, and you need to send this information to some other application. So how can that be done? So suppose I'm just preparing the binary form of it in the form of 101011. That could be anything, but let's assume this is this. And now what you have to do is you have to do some operation in this data with this data. You have to apply an operation with this data. So for that, suppose that you are simply applying a function when you are taking this data and you are just applying some value to it. Okay, say 1010111. This is the data, this is some random value, and you are applying a function which is say JOR. You are doing a JOR operation so that this information is here 1010111. Okay, and while applying the JOR, this becomes 0 111 111 111 101. Okay, so what we did is we just converted the original information into some other form by applying the key and the function. So for any kind of encryption, what we need is a algorithm and the key. Okay, and now when we get this information, say it has some form, I'm just converting into the text. So it got converted into say DXEF. For intruder, it would not be feasible to identify what this information is unless he knows the key, okay, and the algorithm. So if I have this information, I have this function and the key, I can reapply the key to the function to get the decrypted value. So now if I simply apply the same function, same JOR operation and the key to this value, it will be converted to the original value. Okay, so it will be converted to the original value, which is say bridge. So whatever operation we are doing while encrypting the value, the same operation has to happen in a reverse order while decryption. So now when we are saying that the same key will be used for decrypting, so this kind of encryption is called symmetric encryption, in which same key is used. Okay, now think about it. If we have, suppose there are there is some application A and there is another application B. So now to send message to B, I need a key and the algorithm. Okay, and while B receives this value, it need to get the original value, so it need the same key. Okay, and now if A has to send the same message to other application or devices as well, so C also need the key, B also need the key, the same key is being used, and the same way if B has to send back message to A, that will be encrypted via this key, right? So now what is happening is this key is available with different application, so it is vulnerable to be spread across. So if this key is available to some intruder, so there is no point of encryption, because if I have the key, I know the data, I know the algorithm, I can just decrypt the value. So to come up with this, to handle this scenario, there is the another type of encryption, which is asymmetric encryption. Okay, we talked about symmetric encryption, in which key is shared. Okay, now we have the other kind of encryption, which is asymmetric encryption. In this encryption, this is also called a public key encryption. So here what we use is the public key. That means if it is a public, so it can be available to any of the client or with anyone, right? So I am sending this message from A to B. Then whenever I need to encrypt the data, so we have the text, I need to encrypt, so I will be applying some function, which is the algorithm. This we will understand what all kind of algorithm we have. So now I take the text and I need a key, but this time what I need to do is, if I am sending message from A to B, I need a public key of B. That means the public key of B will be shared to A or anyone which B thinks that they can share the information. Okay, so now we applied some function, we get the text. So whenever we are encrypting any value, and after encryption the text which we receive is called the ciphertext. Okay, and this text is going to be shared to the client. This text is traveling in the network. Okay, so now whenever this text is reaching to B, now B would need to decrypt it to get the original text. So what B will do is B will use its public key. B will use its private key. Okay, so B will use the function, same function. It will use the ciphertext, and this time instead of the public key, B will use its private key. Private key of B. Okay. So here it's private key of B. Here it was public key. Now the decryption will happen using the private key. Similarly, if B needs to send the message to A, so B need to have a public key of A, but that's fine. So this is decryption, and while encryption, the same function will be applied, the text and then the public key of A will be used. This ciphertext will be sent over here, and now A will use private key of it and the ciphertext. Okay, and it will get back the text. So in this case, what is happening is the public key is shared. So this public key can be shared among anyone. Until and unless you know the private key, you cannot do with this ciphertext. Suppose I am not authorized to access this data, but I know the public key of B. So whatever data I have, the data which is traveling to the network, even if I know the public key of B, I cannot decrypt this data, because for decryption private key is required. So in this way the asymmetric encryption is safe for the network whenever the data has to travel to the network. So asymmetric encryption is really safe. Now when can we use symmetric encryption? Let's look at that. Okay, so suppose you have a web server. Okay, whenever any request is received by the server, this information has to be logged to identify what's happening, right? So if someone is logging into the system, that information will be logged here in the server, and that log will be stored in some file, some log file. But now if I am saying user A logged in at time some like 11:30 20 p.m. and the date. So now I am printing this information. What if I just don't want this, which user has logged in? I need this log, but I don't want the ID of the user to be printed in the logs. So what can be done? So this information can be encrypted. Okay, here, because this is the web server, I can have the symmetric encryption in which I know the key is available in the server, I am encrypting the value, so now log is there, this information is printed. Now if someone need to identify who that user was, so in the application, while showing the logs, say you are printing these logs in the Kibana dashboard or anywhere, so at that time this information can be decrypted to get the original value A. So all the logging purpose you can use the symmetric encryption. Similarly, if you have received this data and the data has to be stored in the database, suppose some user has a PAN number or bank account number, if this information has to be saved in the database, so in the database this information should be stored as an encrypted value, so that if someone has access to the database, they cannot identify what this value is all about. But while getting back the information, that can again be decrypted. Okay. What else we can use? Where else we can use the symmetric encryption? So now, suppose you have multiple microservices. There is microservice M1, there is microservice M2, and there is M3. Right? Now this is available in the private net, virtual private network. So any information which is traveling to this microservice via the public network should be encrypted using the asymmetric encryption. But if we have to send some information across the microservice in the VPN, that can be encrypted using the symmetric key encryption, because here if I share the key with this guy or this guy, it won't bother, right? Because this key is there in the private network, so no intruder can access this information and you should be safe. Okay, so now what is the point of encryption then? So even if you are using this information within the microservices, because this is your customer's data, if I am a developer who is developing some application, now if I am sending the information such as PAN number or account number, or storing it for that matter in a encrypted form, then it's safe. Otherwise, if I am using this information as flat information, so it is a customer's data privacy, right? So all the app security would not, it won't get passed through the app securities. So you have to store the information of a customer, which is secured information, in the encrypted form. Okay. Now we talked about symmetric and asymmetric encryption. Let's see how can we actually encrypt our data. So we will start with the symmetric encryption first, and we will see what all kind of algorithm we have to encrypt the data using the symmetric encryption. So we will look at a few of the examples. There are DES, which is data encryption standard. Similarly, there is another encryption algorithm which is advanced encryption standard. So we will talk about these algorithms within the symmetric encryption, and we'll see how these applications, how these algorithm works. Okay, so we will start with DES.